Tomorrow's lab is Newton's second law for two objects in motion. We're going to be using the equations that were derived in class on Thursday to theoretically find acceleration and compare it to the acceleration of our experiment. Your experiment will look like this. Please make sure the cart doesn't run into the pulley. I put the masking tape there so it would act as a cushion. We're going to be using the program Data Studio. The program is located in the K drive under Physics. And it's called Newton's Force Lab, as you see here. When you take the data, you're going to get a graph that looks like this. I apologize for recording another computer monitor, but my computer doesn't run the program you're going to be using tomorrow. As you see here, it's a velocity time graph, and right here, the points that I'm highlighting, these are the points that we want to analyze. This is the velocity increasing over time, otherwise known as acceleration, for this cart. What you're going to want to do, as we know, to take the slope of the velocity time graph. I just clicked on the upper left-hand button, scale to fit, and I can see the points that I want. I might even get rid of some of the endpoints just to make sure my data is correct. And we're going to go to Fit, Linear. And I get an acceleration of 0.15 meters per second squared. Now, on to part B. As you can see in part B, I've put the ramp at an incline. And you'll have to read off of the protractor attached to the ramp what the angle is of the ramp. But just like we did in part A, you're going to hit start on the computer and you're going to release the cart, and the motion should look like this. Again, stop the cart before it slams into the end of the track. As you see on the screen, the data of the accelerating car is a straight, positively sloped line, and we're going to once again find the linear slope, and that will give us the experimental acceleration of our graph. Every time you switch stations, please go to Experiment, then kind of delete all. You can see I'm highlighting it in the very upper corner of the video, and hit OK, and it's going to delete the data. For the third and final station, this is referred to as an Atwood's machine. It's a simple pulley with two masses, M1 and M2, hanging over the pulley. You're going to add mass to M1, and that will be the more massive of the two. Here I'm adding a 2-gram mass, and once I do, once I let it go, this is what is going to happen, and this is what the data you'll record. I have a mass difference now. I'm going to let it go, and again, try to catch it. I used really light masses because I knew I wasn't going to be able to catch it, but have one of your partners have their hand right here so you can catch the mass before it slams into the pulley. You're going to analyze the acceleration just like you did with the other two. Find the slope, write and record the data. These are the 3 parts to the lab you're going to do tomorrow.